and then share my screen. All right, y'all. So the first question on this quiz, they're wanting us to, for the following study, identify the population, sample population, parameter, and sample statistic. So we got astronomers typically determine the distance to a galaxy, which is a huge collection of billions of stars, by measuring the distance to just a few stars within it and taking the mean average of these measurements. So they want to know, what is our population? So y'all, the population is what we're taking we're trying to determine the distance of to a galaxy, okay? So the population is going to be all the stars in the galaxy, because that's what we're dealing with. So your population will be the overall scope of what you're trying to measure, okay? Now the sample, well, y'all, we can't measure every star in a galaxy. So we choose a sample. And our sample is going to be the stars that were selected for measurement. Because y'all, like we said, we can't do all stars in the galaxy. So our sample will be the stars that we did select for measurement, okay? So the population parameter, once again, we're talking about the overall population for all the stars. So the parameter, well, let's see what we got. We got the mean distance between all stars in the galaxy and Earth, the distances between each star in the galaxy and Earth, the mean distance between all stars that were selected for measurements, and the distances found in the study. So for us, our population parameter is the mean distance between all the stars in the galaxy and Earth. And that's what they said up here by measuring the distances, okay? So here's the thing, the sample statistic. And let's see, the distances found in the study. Y'all keep having to let people in here. The mean distance between all stars in the galaxy and Earth. Well, y'all, we said that was the population parameter, so it can't be B. The distances between each star in the galaxy and Earth. Well, we can't measure each star in the galaxy. So the mean distance between all stars that were selected for measurements in Earth. So once again, if my sample was the stars that were selected, then my parameter is going to be the mean distance between those stars that were selected. So you would go with a D on that one, okay? All right, y'all. So number 2, they're giving me a sample statistic and a margin of error are given. We want to find the confidence interval likely to contain the population parameter of interest and answer the question. So y'all, let me see what they're saying here. 10 years ago, according to the government records, 17% of the population of Elmwood, so 17% had no health insurance. This year, a poll revealed that 18.6% were without insurance. And that margin of error was 1.6%. So they want me to find the confidence interval for the true percentage without insurance this year. So this new one right here. And then can we conclude that the percentage without insurance has increased from 10 years ago? So let's make our confidence interval. So we're doing it for the new data, the 18.6. So for your confidence interval, the low value, you take the 18.6 and you subtract 1.6. So that'll be 18.6 minus 1.6. That's going to give me the lower end. To get the upper end, I take the 18.6 and I add my margin of error, which was 1.6. So y'all, I would punch them in on my calculator and let's see what we get here. So 18.6 minus 1.6 gave me a 17% on the low end. And then the upper end, we're going to take the 18.6 and we're going to add 1.6. And that gives me 20.2. So based on this data they got with their margin of error, they're saying anywhere from 17% now up to 20.2% now have no insurance. So we got a confidence interval. And y'all, there's only one confidence interval that matches us because we got 17 to 20.2, so it's going to have to be A. So the question was, can we conclude that the percentage without insurance has increased from the 10 years ago? 10 years ago, it was 17%. 17% is the low end of my confidence interval. So we're saying anywhere from 17% up to 20.2% now do not have insurance. So yes, we can say it's definitely went up, and that agrees to our confidence interval. So you take the statistic and you subtract and add the percent of error to get your confidence interval, okay? All right, y'all, so let me put the next page up. So for number 3, they want us to find the mean of the sample data. Well, remember, mean is like the average. So to find the average, we're going to add all these up and then divide by 5 since we got 5 data points. So y'all, we're going to do 20 plus 18 plus 15 plus 20 plus 13, and we're going to divide all that by 5. So one of y'all, if y'all got a calculator, calculate that up and tell me if you get A, B, C, or D. And I'll bring the chat up for y'all. So y'all gonna be y'all gonna add all my numbers, get that answer, and then you're gonna divide by 5. All right, so Morgan, you're getting 17.2. Brown, you're getting 17.2. And the actual answer is 17.2. So these means, they're not bad. You're just adding and dividing by how many you got. So look, this is Hugh Logan's math class, and this is their Scholastic Aptitude Test. Their math scores are shown below. So find the mean. So y'all, that's the average again. So we're going to add all these up. 578, 604, 358, 347, 580, 352, 340, 641, 470, and then 482. So y'all, you're going to add all that up this time. And we're going to take that answer and divide by, what do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to divide that by 10 and see what y'all get. All right, so once again, we're looking for the mean, which is the average. So they gave us the 10 scores. We're going to add all 10 of those and then divide by 10. And y'all doing that in A, B, C, or D? And that's the one thing about statistics that's tricky. Sometimes they give you a whole lot of data, okay? But the more data you got, the more accurate you are. All right, Morgan, you're saying D, 475.2, which is the right answer. All right, also averages, which are our means, we just add and divide by how many data points we had. This one wants the range. The range equals the high value minus the low value. Because the range is just how much is in between your high and low data points, okay? So let's find our highest data point over here. Looks like the 0.617. We're going to subtract our smallest value, which looks like the 0.11. All right, y'all. So A, B, C, or D on that one. Is that going to give me 0.11, 0.547, 0.014, or 0.507? So y'all subtract those and see what we get. All right, Griffin, you're up there. What you got? A D, which is what? 0.507. Good job. So y'all, that one would be D. So that's what's nice about the range. You're just looking at the highest number and the lowest number and doing that little bit of subtraction, okay? All right, now y'all, here's the thing on this one. They're giving me these data points. That's the amount of precipitation of rain in 6 different U.S. cities. They want me to find the standard deviation, okay? So this one I'm going to do by hand. Now, number 7, there's one where they're looking at ball bearings or something, but it gives you 2 different companies. And that one I'm going to probably do on the calculator to show y'all how to use that more, okay? But you could do the ones on the next problem like we're doing now by hand. So I got a note here. If we're going to find standard deviation, the first thing we got to find is the mean. So the mean, you're going to add all them up and divide by 1, 2, 3, 4, 5. We're going to add them up and divide by 6. So we're going to do 13.2 plus 19.6 plus 39.3 plus 48.2 plus 19.4 plus 19.6. We're going to take all of that and divide by 6. That's going to give us our average or our mean, okay? All right, y'all, so let me just punch that in real quick. 13.2 plus 19.6 plus 39.3 plus 48.2 plus, what's that, 19.4 plus 19.6. All right, so what, 6 data points, I hit enter, and then I divide that by 6, and y'all, that's giving me 26.55. So that's the average of these 6 points here, okay? So now, we're going to put each of these values as our X. So I got 13.2, 19.6, 39.3, 48.2, 19.4, and 19.6. I'm going to take each of these points and subtract my mean. That's going to give me the second column, okay? So y'all, I'm going to do 13.2 minus 26.55. That gives me a negative 13.35. 19.6 minus 26.55. That gives me a negative 6.95. All right, then I got 39.3 minus 26.55. That equals 12.75. So if you notice, the numbers that are below the mean will give you negatives. The numbers that are bigger than the mean will give you positives here. All right, y'all, 48.2 minus 26.55 equals 21.65. 19.4 minus 26.55 gives us negative 7.15. And y'all, my last one, 19.6 minus 26.55 gives me a negative 6.95. Now, I take each of these numbers and square them. So 1335 squared equals 178.22. 6.95 squared equals 48.30. All right, y'all, 12.75, square that. 162.56. 21.65, square that. 468.72. So look, finding standard deviation is a tedious little job. Negative 7.15, square that. 51.12. And then finally, my 6.95 negative, square that, and you get 48.30. All right, so once you got all these squared, they're all positive. Now we got to add all these together and get the sum. So y'all, here we go. 178.22 plus 48.30 plus 162.56 plus 468.72 plus 51.12 plus 48.30 gives me a sum of 957.22. All right, y'all. So I now have the sum of all these x's minus their mean squared. So for our standard deviation, that equals the square root of this number, the sum, and that sum is what? 957.22 divided by n minus 1 goes on the bottom. Well, y'all, that's how many data points you have minus 1. So for us, n minus 1 will equal 1, 2, 3, 4, 5, 6 data points minus 1. So that equals 5. So the bottom will be 5. So y'all, to do this problem, I'm going to clear my calculator. I'm going to get the square root first by doing second x squared. That brings the square root up. And then I had 957.22 divided by 5. And y'all, once I hit enter, now we're rounding out 2 decimal places. So this looks like 13.8. So we'll make that 3 a 4 because of that 6 after it. So we get 13.84. All right, y'all, so let's look. And look at that. A is 13. 0.84. Okay, so, and let me write out the whole standard deviation here. So the standard deviation was the square root. This E means the sum. So we did the sum of our x's minus our mean squared. So we squared all those x minus means and then we added them together. And then on the bottom, we did our n minus 1. And n is always the number of data points, okay? All right, y'all, so here's the thing. On that one, I did it by hand, basically. And you see how tedious this standard deviation can be. So what I'm going to do on number 7, let me move my camera back up. On 7, I'm actually going to show you how to do those ones on your calculator. Okay? Because here's what they've given me. Auto transmission manufacturer gets ball bearings from 2 different suppliers. The ball bearings must have a specified diameter of 16.30 with a tolerance of 0.1 millimeters. So recent shipments from the 2 suppliers had ball bearings with the following diameters. So they're giving me A had these, how many is that? 1, 2, 3, 4. A had them 7 measurements. B had these 7 measurements. So they want us to complete A through C. So A, they want to find the mean and standard deviation for supplier A. And then they want me to find the mean and standard deviation for supplier B. So y'all, I'm going to show you how I'm going to enter these into my calculator. I'm going to put these ones under L1 and then B under L2. So y'all, let's go to the calculator. All right, so remember the first thing I do is I hit the stat button because we're doing statistics. And number 1 is highlighted for edit. So you're just going to hit enter for number 1. Now remember, I'm going to clear out this row by arrowing up on that L1, hit clear. When I arrow back down, that row's gone. All right, so L1, I'm going to put supplier A, 16.23. Enter. 16.28. Enter. 16.31. Enter. 16.34. Enter. 3 more. 16.37. 16.42. And then the last one, 16.45. All right, so that's my L1 data. So hit enter on that. Now I'm going to arrow right and get into L2 column. So there's my 7 for A. So this one had 16.18. Enter. 16.21. Enter. 16.23. Enter. 16.36. 16.39. 16.41. And y'all, my last one is 16.46. And enter. So I entered all that data into L1 and L2, so now I'm going to quit that screen. So now let me find the mean for A and the standard deviation for A. So remember, to do math on it, I'm going to hit second stat. I'm going to arrow right and go to math. So my first mean, I'm going to go down here and enter highlight 3 for mean, hit enter. And remember, I put my A stuff in L1, so I need to get L1 by hitting second stat for the list. L1 is highlighted, so I'm going to hit enter. And y'all, when I hit enter, I will get the mean of L1, which is A. So that is 16.34. All righty. Now let me get the standard deviation. I'm going to hit second stat for the list. I'm going to go to math. I'm going to arrow down to number 7, which is standard deviation. Hit enter. And then y'all, I'm going to get L1 again by hitting second stat and enter. Now when I hit enter, I get my standard deviation. So if I'm rounding 2 spots, that's going to be what, a 0.08? Because that 7 is going to round up because of the 7 behind it. So y'all, that is a 0.08. So they're wanting us to round to the nearest hundredth, which is 2 decimal places, okay? All right, y'all, so that was A. Now I can do that for B, which is L2 in my list. So second stat, go to math, hit enter. Whoops, go down to mean, number 3 mean, hit enter. Now I'm doing the mean of L2 this time. So when I do second stat to get L2, I actually got to arrow down and highlight 2. Once I hit enter, it brings L2 on the screen. And y'all, the mean of L2 is 16.32. All right, now let's get the standard deviation by hitting second stat, arrow over to math, and then arrow down to number 7 again for standard deviation, hit enter. And y'all, second stat for our list. Remember, we're doing B, which is L2. So highlight 2 on this one, hit enter. And y'all, when we hit enter, we will have our standard deviation for L2. So 2 decimal places, that's going to be what, a 0.11? All right, y'all, so let me go back to my page now. So yeah, all these are now L1 and L2. I got my data really quick. I didn't have to add all them up, subtract my averages, and all that fun stuff. Now, right here, the reason they're making you do the mean is because if you did them by hand, you had to subtract them all minus that mean, okay? All right, y'all, so draw a box plot for the diameters of the ball bearings from A. So y'all, let's draw a box plot real quick. Now remember, this plot will have whiskers. So my low value and my high value. So for this will be for A, and then we'll do one for B here. So for A, my lowest measurement, let's see, 16.23. So that's my lowest value. So 16.23 is my lowest value. My highest value is, let's see, 37. So they look like they're in order, actually. So my highest value is 16.45. Now we know the mean, we had to find the mean. Our mean is at 16.34. So all we got to figure out is our median for the first quartile and the median for the second quartile. All right, y'all, now notice these are in order here. So the median of the lower quartile will be the one of the lower 3 numbers. Because see, there's my 1634. That was my median of the overall 7. So the middle of these 2 data of these 3 is the 16.28. So that's going to be our lower quartile. And then to get the upper quartile, we look at the median of the top three numbers, which is 16.42. So y'all, for A, you're taking this and you're going to compare it to one of these boxes. Well, y'all, can't be A, they don't even have the box. Can't be B, they don't have the whiskers. So we're kicking those two out automatically. So y'all, let's see what's happening here. So they got my upper quartile at about a 16.4. So that end looks good. Let's see what's happening over here. So this needs to be at 16.28. Whoa, looks like it's a little tight. And this is 16.2. Well, my lowest value was 16.23. So that would have to be on the right side of this. So this left whisker is too far over. So let's look at this one. My lower bound is 16.23. So that could be happening right there. My lower quartile, 16.28. Well, y'all, that can be happening. My median of 16.34 looks like it's in space. My upper quartile, 16.42. Well, y'all, that right line is past to 16.4. And then my whisker is past that. So the one that matches our box plot, we would go with D. And y'all, that's a trick on these. So let's do this one for B here. So we know what our box plot's going to look like. So we're going to kick out B for sure and D because they don't have whiskers and boxes. All right, so of all this overall data, the main median is the middle number, 16.36. All right, my left whisker is at my left value, 16.18. My right whisker is my high value, 16.46. All right, y'all, to get my lower quartile, I look at the median for the first three numbers. Well, y'all, that's 16.21. And then my upper quartile is the median of the last three numbers, and that middle is 16.41. All righty, so then I start looking at these pictures. And y'all, for this one, I'm going to look at A. So let's see, my left whisker at 16.18 is left of the 16.2. 16.21 is a little bit past the 16.2, so I'm good there. My median of 16.36 is less than 0.4, so I'm good there. My upper quartile, 41, well, look, the right side of that is a little bit past, so that's good. And then my right whisker is past that, so that was good. So on that one, I'm just going to go with A and move on. All right, now what I did on this part, I took this 16.30 and it can have a tolerance of 0.1. So I added that and subtracted that from this value. And I'm looking at a value from 16.20 to 16.40. So basically, I'm looking at my confidence interval almost. Okay, I took the 16.3, and they got to be within a tolerance of this. So what we got to look at for number A, any of these that are in between 16.2 and 16.4. Well, y'all, that one is, that one is, that one is, that one is, that one is. Now, these two are too big. They're not within my 16.4. But all these five are. So to get the percent, you take how many that were within those parameters, you divide by 7, and then you'll take that answer, multiply by 100. So y'all do 5 divided by 7 and multiply by 100 and see what y'all get. Oh, accidentally, I think I got the answers already on there, don't I? Let me see if those were what that was from. And notice they're saying round to the nearest integer. So when you do this, you get 0.71, blah, blah, blah. But when you multiply that by 100, you get 71.4. So since that's a 4, I leave that 71. Oh, good job, Michael. Now on this one, they just want you to round to the nearest integer. So when you get 71.43, round that on off to a 71, okay? All right, now let's look. We're looking at the same range on number 2, 16.20 to 16.40. Let's look how many are fitting in between those ranges. Well, 18 don't work. 22 is, 23 is, 36 is, 39 is, but y'all 41 and 46 are too high for my ranges. So this one had 1, 2, 3, 4 out of 7. So 4 good out of 7, and then multiply that by 100. All right, y'all. So doing that one, let's see what we get. 4 divided by 7. That's going to give me 0.57, blah, blah, times 100. I get 57.14, but rounding that to the nearest integer, I rounded that off to a 57. So y'all, that's a trick on this stuff. Now, we could have done these by hand, like I did number 6, but y'all, we got technology to help us, and when you got 2 sets of data, that's the best thing to do is just put them in L1 and L2, crunch your numbers, and then go through these, okay? All right, y'all, so I think there was a number 8 on this one. And y'all, this one just wants me to, let me move back up. This one just wants me to make a box plot for this data. And y'all, I'm looking at my data. It's pretty much in order other than that 4. That 4 needs to be down here to have me in total good order. So that's going to help me on my ends of my box plot. So y'all, let's draw our box plot. Now I'm going to take this 4.0 and I'm moving that 4.0 down here behind that 3.9. I want all my data in order here, okay? So my data will be 1.0, 1.5, 1.6, 2.0, 2.2, 2.4, 2.7, 3.4, 3.4, 3.5, 3.6, 3.6, 3.7 twice, 3.9, 4.0, the one I had to move, 4.1, 4.2, 4.2, 7.0. All right, so we got 1, 2, 3, 4, 5, 10, 15, 20 data points. So 20 data points. But this way I can tell what my lowest number is. My lowest number is 1.0. So 1.0 is going to be my left whisker. And my biggest number is 7.0. So 7.0 will be my highest whisker. Now, to find my median, I take the innermost two data points. So since I got 20, and it's an even number, I got to find the average of 10 and 11 here. So let's count over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my 10th and 11th data points are 3.5 and 3.6. So to get the median, I'm going to do 3.5 plus 3.6 and divide by 2. All right, y'all. So one of y'all got a calculator? Add these together, 3.5 plus 3.6, divide that by 2, and that's going to give us our median. So looks like we're going to get, well, if I add that and divide by 2, looks like I'm getting a 3.55. So 3.55 is the median of all data. Now, to get this lower quartile, the lower quartile is the median of my lower half of data. So I'm looking at the first 10. That's my lower half of data. Well, y'all, this is 10 pieces again. That's an even number. So I got to take the median of the two innermost. So that'll be 5 and 6. So 1, 2, 3, 4, 5 and 6 are going to be the 2, 2 and the 2, 4. So since this one's even again, I'm going to add them together and divide by 2. So y'all, if you add them together and divide by 2, I think you get what, a 2.3 for that. So my lower quartile is 2.3. So now we got to find the upper quartile. To find the upper quartile, we take the upper 10 data points, starting with the 3.6, you do the final 10 here. And remember, since it's an even number, we got to get the two innermost, add them and divide by 2. So let's see, 1, 2, 3, 4, 5. So the two innermost points are the 3.9 plus 4.0. And then we will divide that by 2. So y'all, if you add these together, divide by 2, you should get a 3.95. So my upper quartile is 3.95. So y'all, that's the trick on these. Even number, like there was 20 for the main median. So I took the inner two most out of the 20. For the lower quartile, I did the first half of my data, the first 10. That's an even number. So I had to take the two innermost, divide by 2. So y'all, one of these should match our graph. So let's see. Well, it ain't that one. They're starting with a 0.4. That one's starting with a 0.4. That one's starting with a 0.4. So y'all, ours has to be D because look, we got 1.0, 2.3, 3.55, 3.95, and 7.0. So y'all, we would go with D on that one, okay? So y'all, that is your chapter 5 and 6 quiz, okay? It goes over a lot of stuff you're seeing in chapter 6 as far as the quiz and then the homework, okay? All right, y'all. So I wanted to make a announcement for y'all. Last night I sent y'all an email that has the instructions for the project for stats. Also, I sent a sample stat project. So you can see how I had someone that did it in Word. And what they did, they just copied their charts out of Excel and pasted them in Word. Okay, so if you want to see one that we graded last year that did pretty good, um, I sent that file for y'all to look at. Okay, and then sort of how they got their data, what their data was about, and then how they answered those extra questions there. All righty, y'all realize we're in what week 6 now. So after this week, we got 4 more weeks of class before we wrap it all up, okay? So y'all, any questions? And y'all did really good on that family budget project. Good job, y'all. All righty, y'all. So no questions at all. What we'll do next week, I'll continue on with the next section. Um, okay, so Michael, I'm glad you're on here. I need you to resend your file for me because when I pulled it up, it wouldn't open it up. It was the way it was named or something. It was doing it like a dot numbers file or something, and mine won't really open that for me. So um, I'll have to have you convert that one into another format or text me your pictures from it. All righty, y'all. So yeah, Michael, as soon as I get it though and I can open it, I'm gonna get that graded pretty quick, okay? Right, y'all. So anyone on vacation right now? Oh, Pamela, you done got back apparently, huh? Yeah, me too. All righty, y'all. So y'all, I don't have nothing else. So if I don't guess I see any questions, so what I'll do